All right, let's dive into something pretty amazing. Earth's magnetic field. You know, that invisible shield protecting us from like cosmic rays and stuff,
Yeah.
guiding, everything from those migrating birds we always hear about
Ah,
to ships out there navigating the ocean. But this force, it isn't static. It's constantly changing. And right now,
yeah.
that magnetic North Pole, it's on the move, drifting towards Siberia. And it's happening really fast.
And what's fascinating about that is this shift. It's not just some abstract scientific thing, it's got real world consequences, potentially affecting everything from how we navigate
Yeah.
to like the balance of wildlife migration.
Exactly. So in this
Yeah.
deep dive, we're not just going to unpack the science behind it all, but also explore those broader implications.
Mhm.
Think, disrupted GPS, challenges for those Arctic expeditions,
Yeah.
and even potential risk to satellites and power grids.
Yeah. To understand why this is such a big deal, we've got to start at the heart of it, Earth's core, deep down there. There's this constant churning of molten iron and nickel, creating this massive planetary dynamo.
Okay, so like a giant molten engine powering this invisible force field. I'm trying to imagine the scale of that.
It's really mind-boggling. Like, imagine a sphere of molten metal, larger than the moon, constantly moving. That movement generates these electric currents. And those currents then create the magnetic field that surrounds us.
So this isn't just some like theory. It's a real physical phenomenon, tangible effects. It's what makes a compass point north, right?
Precisely. And it goes way beyond our compasses, like migratory animals, birds, sea turtles, they rely on the magnetic field for navigation. They've evolved to sense these lines of force
Right.
and use them as like an internal GPS.
Wow, so they're tapping into this natural navigation system that's been around for millions of years. That's incredible. Well, we're talking about this system being in flux now, right? The magnetic North Pole isn't staying put.
Exactly. It's always been in motion. But it's really sped up in recent decades. We're talking like a shift of up to 55 kilometers a year towards Siberia. Like it's on this high-speed journey.
Wow, yeah, that's a pretty big shift. It makes you wonder if those migrating animals are feeling lost. You mentioned navigation systems being affected too. What's the connection there?
Well, our modern navigation systems, like the GPS on your phone, or the systems used by aircraft and ships, they rely on a model of Earth's magnetic field called the World Magnetic Model, the WMM.
So it's like a magnetic map. That helps these systems pinpoint their location.
Exactly. But if that map is based on a moving target, it becomes less accurate over time.
Okay, that makes sense.
Yeah.
So as the magnetic North Pole keeps drifting, our navigation systems could start going haywire.
Exactly. And the faster the pole moves, the more we need to update those systems. We're talking about potential disruptions to
Yeah.
everything from commercial flights to like maritime shipping, especially near the poles where magnetic navigation is so important.
I'm starting to see why this is such a big deal. It's not just about compasses being off, but potential safety issues for aircraft, ships,
Yeah.
and even people using GPS.
Right. One really striking example is the challenges faced by polar expeditions. Those teams often rely on magnetic compasses for navigation in extreme environments.
So if their compasses are off,
Mm.
they could end up miles off course, lost, and even in danger.
Exactly. Imagine trying to navigate this vast icy landscape with low visibility. And your compass is wrong. It shows how reliant we are on this force.
Yeah, it's like the ground beneath us is shifting, literally and figuratively.
And it goes even further. We've talked about navigation, but what about those animals that rely on the magnetic field for their own compass?
Right, we talked about the birds and sea turtles. If their magnetic map is changing, could that disrupt their migration and even affect their survival?
It's a real concern. These animals have evolved for millions of years to rely on this stable magnetic field, but with the poles shifting, their sense of direction could be thrown off.
It's like they're following a map that's constantly being redrawn. And if they can't adapt, it could be devastating.
Exactly. Like take sea turtles. They use geomagnetic cues to go back to the beach where they were born, to lay their eggs. If those cues are disrupted, it could mess up their whole reproductive cycle.
That's both fascinating and sad. I hadn't thought about it on that level.
Yeah.
We're messing with the very fabric of their existence. But beyond the ecological consequences, there's also the potential impact on human health, right?
Yeah,
I read something about the magnetic field protecting us from cosmic radiation.
you're right. It acts like a protective barrier, deflecting that harmful radiation from space. But as it weakens and shifts, that shield becomes less effective.
So we're talking about being exposed to more cosmic rays. What does it mean? Like, I know radiation is bad, but
Well, Increased radiation can have all sorts of consequences. It can disrupt satellites, cause issues with power grids, even pose risks to astronauts and people on those high-altitude flights.
Wow, so it's not just theoretical. We're talking real impacts
Right.
on our technology and our health.
Exactly. It shows how interconnected everything is, how changes in one area can have these ripple effects.
Okay, so we know this magnetic shift is important, but I'm curious what's causing it. Is it something we're doing? Or is it just, Earth being Earth?
It's definitely Earth being Earth. It all goes back to that molten metal in the core, those movements. They create turbulent flows that drag the magnetic field along, like swirling currents in a river carrying things downstream.
So it's like this cosmic tug of war happening deep inside the planet.
That's a great way to put it. And these flows are influenced by so many things: Earth's rotation, the core's composition, the heat transfer from the inner core. It's complex. Scientists are still working to understand it all.
It's amazing to think about. But we've got brilliant people working on it.
We do. And this is where things get a little sci-fi. To study and predict these movements, they use what are called geodynamo simulations.
Yeah.
They create virtual models of Earth's core inside these supercomputers to try and replicate those conditions.
It sounds like something out of a movie.
Yeah.
So building digital Earths to understand the real one?
Exactly. And by running these simulations and comparing them to what we see happening, scientists can test their theories and get a better understanding of the magnetic field.
That's fascinating. It's like we're peeling back layers of an onion. With each layer, we see more intricate details about our planet. I'm definitely eager to learn more, but I think this is a good place to pause for now.
I agree. It's a lot to process, but I think we've built a good foundation for understanding Earth's magnetic field and why these changes are so important. Yeah, and it really shows how much we don't know about what shapes our planet. It's like we're always discovering something new.
We keep talking about that magnetic North Pole, racing towards Siberia, but it's not like it's got a finish line, right?
Yeah.
What happens when it gets there? Does it just stop?
That's a great question. And scientists are still trying to figure that out. It's unlikely it'll just stop. The movement is driven by those complex flows in the core, remember, the magnetic North Pole. It'll probably keep drifting, but predicting exactly where it'll go is tough.
So it's more like a cosmic wanderer, roaming around. I guess that makes sense with what we've learned about the core. Speaking of big changes, though, we talked about the possibility of a full pole reversal. That sounds pretty intense. Is that something we need to worry about? Or is it more of a slow process?
Well, it's definitely not happening overnight. These reversals take thousands of years. The last one happened about 780,000 years ago.
Okay, so we've got some time. But what actually happens during a reversal? Does everything just flip around? Do compasses start pointing south?
Basically, yeah. The magnetic field weakens, the poles wander, and then they flip. Your compass would point south instead of north. But it's not as crazy as it sounds. The field doesn't disappear. It just kind of goes through this unstable period and reconfigures itself. Think of it like a dance, where the partners switch places, but they keep dancing.
Okay, that makes sense. So more of a gradual transition, not a sudden catastrophe. But what would happen in the real world? Would we be walking around upside down?
Not quite. But there are some serious things to consider. One of the big worries is what could happen to our technology. During a reversal, that magnetic field weakens, and that makes us more vulnerable to solar storms and radiation.
So more power outages, problems with satellites,
Yeah.
damage to our devices. Basically, everything goes haywire.
You got it. And remember, we're only becoming more reliant on technology. Our world runs on electricity and networks, so the stakes are high. Plus, like we talked about before, a weaker field can mess with animal migration, impacting those ecosystems and biodiversity.
It's like a domino effect. One change triggers all these consequences. It's fascinating, but also kind of scary to think about.
It is. It shows how important research and monitoring are. The more we understand, the better we can adapt.
Okay, so we've talked about the North Pole moving
Yeah.
and a full reversal. But what about in between? Are there any other weird things happening with the magnetic field?
Another good question, and the answer is yes. One interesting one is the South Atlantic anomaly. It's a huge area where the field is much weaker than normal, and it's been growing lately.
So we've got a speedy North Pole and a weak spot in the South Atlantic. Sounds like the magnetic field is having a midlife crisis. But seriously, how does this anomaly affect us?
Well, remember how the field protects us from radiation? This anomaly is like a weak spot in that shield.
Okay, so more radiation getting through there. What does that mean?
It's a problem for satellites. When they pass through this area, they're exposed to more radiation, which can damage their electronics and even shorten their lifespan.
That's not good. Can we protect those satellites? Or do we just have to hope for the best? We rely on them for so much.
There are things we can do to reduce the risk. Satellite designers know about this anomaly, and they build in shielding and backup systems to make them tougher. It's like giving a spaceship extra armor to survive a cosmic attack.
So they're building tougher satellites. That's good to know.
It is. And as we learn more, we can come up with even better ways to protect our tech in space, like improving our space weather forecasts, for things like solar flares, which can make the radiation worse.
It's like a race to stay ahead of the game. But it's good to know people are working on it. So we've got this weak area in the South Atlantic. Are there any other anomalies, or is that the main one?
There are some smaller ones, but the South Atlantic anomaly is the biggest. And the one that has scientists really interested, it's kind of a mystery why it formed and why it's growing, but researchers think it's connected to things happening deep in the core.
Like a giant puzzle we're trying to solve.
Exactly. And every new piece of information helps us understand this system.
Okay, so we've got this incredible force around our planet, protecting us, guiding animals, affecting our tech. And it's not just sitting still. It's always changing, shifting, even flipping its poles.
Yeah.
It's mind-blowing.
It really is. It shows how much we still have to learn about our own planet.
I feel like every time we do one of these deep dives, we end up with more questions than answers. But that's what's so cool about science, right? It's all about discovering new things.
Absolutely. And with each discovery, we appreciate our world even more.
Speaking of cool discoveries, you mentioned those geodynamo simulation scientists use. Can you tell us more about those? What do they look like, and how do they help understand the magnetic field?
Imagine a massive supercomputer crunching all this data and creating visuals that look like a cosmic lava lamp. That's kind of what geodynamo simulations are like. They create these really detailed 3D models of the core, showing how the molten iron moves and those complex patterns of the magnetic field.
So we're seeing this molten ballet deep inside the planet, and they use real data for this.
Yes, they use measurements of the magnetic field from observatories and satellites, seismic data that shows the Earth's structure, even info about Earth's rotation and gravity.
Wow. It's amazing that we can create virtual worlds to understand the real one.
It is, and these simulations are getting more advanced all the time. They're helping us predict how the magnetic field will behave, which is so important for everything, from navigation to protecting our tech from space weather. One of the biggest things we've learned is how the flow of that molten iron affects the poles.
So it's not just seeing what's happening, but figuring out why. And these simulations are helping us do that. Sounds like we're making real progress.
We are, but it's a continuous process, always more to learn. Earth is a complex system, and the magnetic field is just one part of it.
Okay, we've covered a lot. The South Atlantic anomaly, those geodynamo simulations, and what could happen if the poles reverse. Before we move on, let's think about everything we've learned about this force. It's pretty remarkable.
It is. It shows the power of science and how curious we are about the world.
Yeah, it really makes you think. Like the ground we stand on, it's not as solid and steady as we think. But speaking of change, we've talked about the downsides of the magnetic shift. Navigation problems, risks to satellites, even our health. But are there any, upsides? Could there be any good things that come from this change?
That's a good question, and scientists are looking into that. One possibility is that this shifting magnetic field could help us study the Earth's interior better. As it changes, it gives us this kind of moving window into the core.
So it's giving us clues about what's happening deep down, like a natural MRI of the planet.
Exactly. By looking at those subtle changes in the field, scientists can learn about the flow of molten iron and the things that drive plate tectonics. It's like this giant natural lab under our feet.
That's pretty amazing. So even though these changes cause problems, they also give us a chance to understand our planet better. I guess change is always a mix of challenges and opportunities.
Definitely. And who knows what other discoveries are waiting for us as we explore more of the magnetic field.
I like that sense of possibility. Even with all the uncertainty, there's always something new to learn. Okay, before we finish up, let's go over some of the key things we talked about. We started with that magnetic North Pole, speeding off towards Siberia, and how that's messing with navigation systems, wildlife migration, and maybe even our health because of that radiation.
Right. We also talked about the South Atlantic anomaly, that area where the magnetic field is weaker, and how that's a problem for satellites. And then there's those geodynamo simulations, those computer models that are helping scientists figure it all out.
Yeah, and we even touched on what could happen if the poles completely flip, which just shows that our planet is always changing on a much bigger timescale than we're used to. But I think the most important thing to remember is, even though these changes can be scary, They also give us a chance to discover new things and to come up with new solutions. We're learning to adapt and understand this force that shapes our world.
I agree. It shows that we're part of this big dynamic system. And by learning about it, we can deal with whatever changes come our way.
That makes sense. I have one last thing to leave you with. If something as constant as the Earth's magnetic pole can change, what else in our world might be more dynamic than we think? Our ideas, our beliefs, maybe even how we see the universe is something to think about as we keep exploring and learning. Thanks for joining us on this deep dive into the Earth's magnetic field.